Section 2.8A, an intro to linear programming. So we need to know some vocabulary. A constraint is any of the inequality statements. A feasible region is the intersection of the constraints. Which is going to be all your overlapping shading. Vertices, those are the points of intersection. Where the constraints meet. Bounded means that there's a closed region. Of the constraints. So typically that will happen, well, it will happen when you have 3 or more constraints. If you only have 2, then it's going to be unbounded, so that's going to be an open region. So anytime we've just graphed the 2 inequalities, we end up with an open or an unbounded constraints, because that's going to go on in that shaded region forever. So, and a feasibility statement is f of x comma y, and it is a given statement used to find maximum and minimum values. Okay. So linear programming can be used anytime you can come up with an equation or an inequality that is linear in nature, and then you'll figure out like cost of things, and then you can figure out the best way to maximize and minimize profit. So if you're selling a couple of things and you want to know, okay, what's the best combination to sell to make the most money, then you're going to use some linear programming. So this is one of those real life applications. Okay, this is a simplified version of linear programming, since it's just the first time you've ever seen it. So here we go. So graph each system of inequalities, name the coordinates of the vertices of the feasible region, find the maximum and minimum values of the given functions for this region. So here we have 4 inequalities, and we have to graph all 4 of them. So x is less than or equal to 5. That's a vertical line that goes through 5 on my x-axis. It's equal to, so it's going to go like that. And then I'm just going to shade really, really light. I'm going to find where I put my pencil. Just to keep track. So x is less than that, so less than. Okay, well, happy there. Okay, and then y is less than or equal to 4. So that goes through 4. So y is less than that. Okay. X is greater than or equal to 0. That's our y-axis. And x is greater than. So this way. And lastly, x is greater than or equal to 0 is our x-axis, and x or y is greater than or equal to. So holy cow, that's a lot of shading, right? So with this, you're looking for where does everything overlap. It's going to be the area that basically the only part that's going to touch all of the lines that we just graphed. Okay, so this little rectangle here is the part where all those lines, that will touch all 4 of the lines that we just graphed. Okay, so now we need to figure out what the vertices are, and it doesn't matter which order you write them in. So here, it's these 4 corners of our little rectangle. So we have the point 0, 0, you have the point 5, 0, we have the point 0, 4, and we have the point 5, 4. So this little table of values is just to help you organize things. We have our feasibility statement here that says f of xy is equal to 3 times your x plus 2 times your y. So 3 times my x value plus 2 times my y value, 0 plus 0 is 0. 3 times my x, so 3 times 5, plus 2 times my y, which is 0, so 15. 3 times 0 plus 2 times 4 would give me 8. 3 times 5 plus 2 times 4 would give me 15 plus 8, which is 23. So my biggest, my max value is 23, and it happens at the ordered pair 5, 4. And my minimum value is 0, and it happens at 0, 0. So if I was selling something, I could sell, 5 of one, 4 of the other, and that's going to give me the best combination to make the most money. Okay, so you can see I would, I'd make something at this order if I just did 5 of the one, or if I just did 4 of the other, but to get the most out of it, I'd want to do that. Okay, let's try again on the next example. So this time we only have 3. We need them all in slope-intercept form. So I'm going to subtract x. So y is less than or equal to negative x plus 4. So start here at positive 4. My slope is negative 1. So down 1, right 1. Or up 1, left 1. It is equal to, so we have a solid line. Okay, and I'm going to wait to do the shading until I've got all my lines drawn. So y is greater than or equal to 1. That's a horizontal line through one of my y-axis. Okay. So that's one point of intersection. And the other one, x is greater than or equal to 0. That's my y-axis. So it goes through the point 0 on the x-axis. Okay. And so there's a part where we're going to shade. It's where all of our pieces meet. I'm going to draw in those intersections a little darker. And so the only piece in that whole graph that touches all the lines is just that little triangle there. Okay. So my vertices in this case are 0, 1, 3, 1, and 0, 4. Okay. So this time my feasibility statement is f of xy is equal to x plus 3y. So in this case we had 0 plus 3 times 1. So that would be 3. 3 plus 3 times 1 would be 6. And 0 plus 3 times 4 would be 12. So my maximum value is 12, and that happened at 0, 4. My minimum value is 3, and that happened at 0, 1. Okay, and our last example. Okay, so we've got 4 inequalities again. We need them in slope-intercept form, so y is less than or equal to negative x plus 8. So start at 8. Slope is negative 1, so down 1, right 1. Solid line. And we'll subtract 2x, so y is less than or equal to negative 2x plus 10. down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Okay. X is greater than or equal to 0 is our y-axis. And y is greater than or equal to 0 is our x-axis. Okay, so this one's a little tricky because it looks like we've got this triangle that's closed in, this triangle that's closed in, but it has to touch all 4 lines. So it's this quadrilateral. Okay, so then we need to look where our intersection points are. So we have 0, 0, 5, 0, let's see, what is that, 2, 6, and 0, 8. This time our feasibility statement is x minus y. So 0 minus 0 is 0, 5 minus 0 is 5, 2 minus 6 is negative 4, and 0 minus 8 is negative 8. So our max is 5, and that happened at 5, 0. And our minimum is negative 8, and that happened at 0, 8. All right, good luck. If you have any questions, talk to your math teacher.